Expectation of a random variable. Session prerequisites. Browse to our earlier material on random variables. Learning objectives. Partitioning a continuous variable, for example stock movements, into bins. Mapping the bins to a new discrete random variable. Calculating the expectation of this random variable. In preparation, please have the spreadsheet open on your computer and follow along. Maximum benefit guaranteed.
Welcome back, I'm Shankar and we are discussing the topic of random variables in Statistics for Business 1.
I'm Liza and I meet all your expectations.
Really? Well, we spoke about them in our earlier segment. We use random variables to describe a process whose outcomes cannot be determined in advance.
Like the stock market?
Most definitely. We continue to analyze movements of two stocks in the Indian software sector. Many thanks to CMIE for helping us with the data. We'll call our firms Software X and Software Y. In our last segment, we described a random variable visually using the probability mass function or PMF and the cumulative distribution function, which is CDF. But visuals alone aren't necessarily helpful when several variables are involved, like with a large portfolio of stocks. In this segment, we'll discuss ways to numerically summarize a random variable. We begin by calculating the expectation of a random variable from its underlying distribution. Let me begin by stating a disclaimer. I'm no financial guru, so don't take my simplistic line of reasoning for actionable wisdom. Leave that to folks who work with stocks for a living. Earlier, we had asked these questions of our two stocks data set. Let's assume that I have purchased one share of Software X. Now, as you can see from this stock's movements, it can either go up, come down, or stay put. And that is from month to month. We could use COUNTIF statements to build a table of directional movements. I will leave it to you to figure that out. Now looking at this table, both the stocks have a great propensity to climb up than to go down.
Thank God. And the stock market.
It's not enough to know whether the stock has gone up the next month. What also matters is by how much. In our last segment, we time differenced the prices to get movements for Software X. We then created a frequency table. Based on these bin values, we'll now define a new variable X, which will roughly represent our stock's movements over a month. Just keep in mind, X is not the stock price, it's a movement. Notice that our new variable X takes these values over here, there are 8 of them. They are our bin values.
These values don't look pretty.
That's the real world for us, Liza. Instead of focusing on exact numbers, what we have done is to consolidate stock movements using our bin values. That's what you see in our table. Over 2 decades, our numbers tend to follow a trend which is captured by probabilities. Looking at our table, the next month's close price can be up anywhere between 8.23 to 82.9. And we say it has moved up by 45.57. It's time we took up our first question.
How much money can I expect to make when I buy one share of a firm and hold on to it for a while?
Thanks, Liza. We'll purchase one share of Software X and use our discrete random variable X for the analysis. The bin values corresponding to the actual movement are in the mapping column. If these were the only movements possible, then our question would take an easier form.
What's the average of this column?
And that's the right answer. It's nothing but a group mean, which we have already gone over. We can also express this average using the outcomes of X and their probabilities. We get a summation outcome 1 times probability 1 plus so on plus outcome 8 times probability 8. This summation is called the expectation of our random variable. Mathematically, we write E of x as sigma I, value I times probability I. On our spreadsheet, this is just a sum product. Let's go ahead and do this. So I have my expectation here as the sum product of the bin values, or rather the probabilities, times my bin values, both of them are one and the same, and I get rupees 3.112. Let's compare this with the actual average of the stock's movements. I've compiled a bunch of summary stats over here, and my mean is rupees 8.23.
That's way off the mark.
That's where you, my dear student, should step in. We've reduced nearly 240 stock movements down to 8. What if we had doubled these bins?
I see an exercise coming. Good luck.
How did you guess that? To answer this question, suppose we had to rely on a rough distribution of stock movements and we were not given the exact stock prices. We just came up with an answer using our approach of taking expectations. The answer gets better with the bins getting smaller.